Alright, this video is over solving trigonomic equations. The first thing I need you to realize before we even start this video is that solving trigonomic equations is really no different than solving regular equations. So every strategy you could possibly think of that you've used in the past to solve linear equations, quadratic equations, cubic equations, square root equations, you might use some of those same strategies to solve trigonomic equations. Alright, so the goal is to treat the trig function like its own variable that you must solve for. So again, you're trying to treat that trig variable just like it's x back in an old algebra problem. You're trying to solve for it. However, once you solve for it, you must consider what angle satisfies the statement. And for this to make complete sense, let's take a look at two examples. I think this will make a lot of sense to you. Alright, in this first example, what I'm going to do is I'm going to treat the sine of x, the trig function, like it's its own variable, right? Like it's maybe w. So how do I solve for w? Well, I'm going to subtract 5, so I get 2 sine of x equals 1. Then I'll have to divide by 2, so I get sine of x equals 1/2. So I basically have solved for w, right? I've solved for my trig function. Now I have to ask myself, what angle x, right? X is an angle. What angle has a y-coordinate on the unit circle of 1/2? Well, once again, what I'm going to do is I'm going to go and grab my unit circle right here, and I'm going to look. Where do I see a y-coordinate on the unit circle that has a variable of 1/2? Well, I see it happening right here at 30 degrees. At 30 degrees, I see a y-coordinate of 1/2. I also see it happening here at 150 degrees. So actually, there's several different ways to answer this question. First off, if I only want answers that are on the unit circle, then there would be two answers, 150 degrees and 30 degrees. Again, both 30 degrees and 150 degrees have a y-coordinate of sine, or a sine value of 1/2. Okay? Now, if I want all answers, I have to consider the fact that if I add more trips around the circle, if I continue to go around the circle, adding 360, or even subtracting 360 degrees, as many times as I want, I could get more and more answers. So adding and subtracting 360 times n shows that you can go around more and more and more and more and more and get more and more and more answers. N is just how many times you keep going around and around in a circle. But usually I like to stick with only finding answers that are on the unit circle. Then your answers would simply be 30 degrees and 150. Don't also forget about radians. You could be pi over 6 or 5 pi over 6. I don't want you guys to forget that sometimes you might get an answer that's in radians. You got to read the question to know. Now let's take a look at this one over here. Let's see here. I'm going to treat the sine of x like it's its own variable. Let's call it m this time. I want to solve for m. First step is to add 2. So I get 8 sine of x equals 7. Next step is to divide by 8. I get sine of x equals 7 over 8. So once again, what angle, if I plug it in, will give me a y-coordinate on the unit circle of 7/8? Well, I'm looking on my unit circle, and I don't see a y value of 7/8 anywhere. First off, I have to think, is 7/8 even possible? Well, 7/8 is less than 1, so somewhere up here there will be 7/8, right? 7/8 is approximately 0.875. So somewhere around 0.875, because remember, the very, very top here it's 1, I will get a y-coordinate of 7/8 or 0.875. So it does happen somewhere, but how do I find out where? Well, this is where we would need to use inverse trig functions. So I would have to say, okay, x would equal the inverse of 7/8. The inverse of 7/8. So if I go to my calculator, make sure you're in degree mode. I am going to talk about degrees in this video. Make sure you're in degree mode. Please do the inverse of 7/8. And we get an angle of 61.04 degrees. So 61.04 degrees. So at 61.04 degrees, I will have that y-coordinate becomes 7/8. Now, on the unit circle, we have to understand that the inverse function can only give us answers in quadrant 1. So that means that there's another answer that is mirrored over to the other axis, right? So if I do 180 degrees minus 61.04 degrees, I would actually get another angle that's in the second quadrant where this happens as well. So if I take 180 degrees and subtract 61.04, I get the fact that there is another angle of 118.96 degrees where the sine value is 7/8 as well. And that's because, again, the inverse only gives me one answer. I have to think about where that other answer is. Now, pretty cool. You can check your work. Just type in sine of 61.04, right? Regular sine, not sine inverse. And you should get something very, very close to 7/8. It's not exact because we rounded. Same thing, do sine of 118.96 degrees on your calculator. And again, you will get something very, very close to 7/8, which is 0.875. Might not be exact because of rounding, but it should be pretty darn close. So sometimes you can use this unit circle to find your answers. Sometimes you got to use inverse trig functions. All right, let's take a look at a couple others. All right, this next one, example 3, is pretty good. I'm going to treat this tangent function as my variable. I'll call it a. Now, the first thing I notice is that it's tangent squared. So that's going to become like an a squared. So I do have to handle that as well. So first step would be to subtract 5. I get 3 tangent squared of x equals, let's see, 14 minus 5 is 9. Now I'm going to divide by 3. Tangent squared of x equals 3. 9 divided by 3 is 3. Now I got to get rid of that square root. To get rid of a square root, I'm going to take the square root of both sides. Now I get tangent, which is nice. I've isolated my trig function. But be careful. Anytime you take the square root, you must put a plus or a minus in front of that square root of 3. So now I'm trying to find where on the unit circle do I see an angle where tangent is either positive or negative radical 3. And I'm looking over here. Oops, sorry about that. I'm looking over here at where this potentially happens. And, wow, it actually happens in quite a few places, especially what I consider that it could be positive or negative radical 3. So let's see, right here at 60 degrees, tangent is positive radical 3. At 120 degrees, tangent's negative radical 3. At, let's see here, 240 degrees, tangent is positive radical 3. And all the way down here at 300 degrees, tangent is also negative radical 3. So I have several answers. I have 60 degrees, 120 degrees, and don't forget I could put my answers in radians. I have 240 degrees and 300 degrees. 240 degrees and 300 degrees. So those are the 4 places on my unit circle from 0 to 360, or all the way around the circle, one circle, one revolution, where this could potentially occur. So pretty cool, pretty easy to do that one. All right, let's take a look at this next one here. Here is cosine of x. That is the trig function I'm going to solve for. I'll call it let's call that t. Just treat it as a variable, right? Just got to solve for t, no big deal. So let's see. First thing I'm going to do is subtract that 6. So I get 3 cosine of x equals 5. And cosine of x equals 5/3 after I divide by 3. So now I'm thinking, where on my unit circle is cosine, or where on my unit circle is the x value 5/3? So I'm trying to figure out what angle, right? That's what x is. X is an angle. What angle will produce a value of 5/3? Well, first off, I'm looking around my unit circle here, and I don't see 5/3 anywhere, right? So might have to go to my inverse trig functions. But wait a minute. 5/3 is bigger than 1. And we know that on the unit circle, a cosine value will never, ever, ever be bigger than 1 or smaller than -1. So I actually know that there is no solution here. The reason why there's no solution is there's no angle in the world that will create a cosine value of 5/3, which is bigger than 1. Now, if maybe you didn't catch that at first, you could use your inverse trig function. You'd use an inverse cosine of 5/3, and you would use your calculator, and it would tell you error, does not exist, cannot happen. Hopefully you understand why now. Okay, let's move on to a couple more problems here. Now we're going to take a look at a couple other situations. Sometimes you may see a trig function multiple times. This is no big deal, right? This would be similar to seeing a problem like this. 3x minus 4 equals 5x plus 2. Okay, you got an x, you got a variable on both sides. No big deal. We know how to handle that. All you got to do is be able to combine variables. So I have the same problem here. I have a sign on both sides. This should not be a concern. All I got to do is move them all to one side. So I'm going to take this minus sign right here, and I'm going to add it over. So when I add that over, I get 2 sine of x plus radical 2 equals 0. All I did was add this sign over to here and combine it with this like term. Now I'm going to continue to solve for sine. So I get 2 sine of x equals radical 2. And now I'm going to divide by 2. I get sine of x equals radical 2 over 2. And this is something that I instantly recognize happens on my unit circle. So I'm trying to figure out what angle will allow a sine value to be radical 2 over 2. Well, let's see, I see it happen right here at 45 degrees, and I also see it happen over here at 135 degrees. So I see it happen at 45 degrees and 135 degrees. Now, one more time, if my answer says only find answers on one circle 0 to 360, these would be my only two answers. If I want to find all possible answers, I would need to add and subtract that 360n, and that's just referencing the idea that I can go around this circle multiple times, and I would continue to find places where sine is radical 2 over 2. So don't fret if you see multiple trig functions. Okay, another strategy is when you have multiple trig functions. When I say multiple trig functions, I mean, like in this example, cosine and cotangent. The trick here is to think about factoring to help you. But remember, if you're going to factor, you must have a 0 on one side first. So when I see the fact that there's two trig functions, this is like a problem where there's a's and b's, right? This would be like a times b squared equals 2a. Well, how do you solve an equation with two variables? Well, it's pretty hard, but not with trig functions. It's not, and not with factoring. Well, here's the idea. First thing I'm going to do is I'm going to subtract the 2 cotangent over. Because remember, I cannot factor until I have a 0 on one side. So I have cotangent x times cosine squared of x minus 2 cotangent of x equals 0. Now what I'm going to do is I have two terms here. Remember, terms are anything separated by a minus or plus sign. So I have this first term right here, cotangent times cosine squared, and I have this back term right here, 2 cotangent x. So what I'm going to do is I notice that there's something common between both terms. There's a cotangent of x that's common. So I can actually factor out that cotangent, and I get cosine squared of x minus 2 left over. If you don't believe me, just distribute the cotangent to see that I do end up at that same answer. Now what I'm going to do here is I'm going to use actually something called the zero product property. The zero product property says if you have two values, a times b, and they equal 0, then either a equals 0 or b equals 0. And that's exactly what I have going on here. I have two things. I have cotangent being multiplied by cosine squared minus 2, and they equal 0. So one of these things must be 0. So either cotangent of x equals 0, or cosine squared of x minus 2 equals 0. So now I just got to solve each one of these for possible solutions. When is cotangent 0? Well, let's see here. When is cotangent 0? Okay, cotangent is the x value from the unit circle divided by the y value. So I'm going to look at my unit circle. Where is the x divided by y 0? Looks like it happens up here at 90 degrees. X divided by y would be 0. Also happens down here at 270 degrees. So my possible answers are 90 degrees and 270 degrees. Those are the two places on the unit circle where x divided by y is 0. All right, now for this next one I got to solve. Let me add 2 to the other side. Cosine squared of x equals 2. Let me take the square root of both sides. Cosine of x equals, don't forget the plus or minus, the square root of 2. Now here's the problem. The square root of 2 is approximately 1.4. Well, wait a minute. A cosine value cannot be positive 1.4. That's bigger than 1. Nor can it be less than negative 1.4 because that's smaller than negative 1. So it appears that this part of the equation has no solutions. So, lo and behold, the only two solutions I have were the 90 degrees and the 270 degrees. So that's a nice problem where you realize that the only way to solve that type of problem is to factor. All right, here's two more problems where you need to factor. This first one, the factoring is actually already done for me. I have tangent x plus 1 times sine of x minus 5. Once again, the zero product property says when two things are being multiplied, one of those two things must be 0. So tangent x plus 1 could be 0, or sine of x minus 5 could be 0. Let's solve this one first. All I got to do is subtract 1 to the other side, and I got to figure out where is tangent negative 1. Well, let's see here. On my unit circle, tangent is negative 1 at 135 degrees. Y divided by x is negative 1. And also down here at 315 degrees, it happens as well. So at 135 degrees, and 315 degrees. Now, don't worry, you're going to have to use your calculator. If all else fails and you were like a little bit confused on this one, you could have done an inverse tangent of -1 to get your angle, and it would tell you 135 degrees. You would just have to know, actually, it would tell you, I take that back. Actually, let's do that real quick. The inverse tangent of -1. The calculator reads -45 degrees, because remember, that's the only value the calculator is allowed to give me. Now, you need to understand that -45 degrees is exactly the same as 315 degrees. And then on top of that, you need to understand that this same value, where tangent is -1, occurs a half a circle away, all the way directly across, a half a circle away in quadrant 2 at 135 degrees. So make sure you understand how I'm able to get all of these answers even if you use inverse trig functions. Alright, this next one's actually real easy. Let me just add 5 to each side, and I'm immediately going to stop and say no solutions. Hopefully by now you know exactly why there's no solutions. Sine cannot be 5. Alright, this next one needs factored for me. Best news is I already got a 0 on one side. Don't attempt to factor until you get a 0. Well, I'm going to treat sine of x just like it's a variable, right? Maybe you want to treat this as 2a squared minus a minus 1. All I got to do is factor that. So let's see, that's going to be 2a times a, and then I'm going to need a 1 and a 1, and let's see here. I need that to be a negative there and a positive here. That way I get a 2a squared in the beginning, I get a negative 2a, and a positive 1a in the middle, giving me that negative a in the middle, and then a negative 1. Well, now let me put the trig back in. Basically, this is 2 sine of x plus 1 times sine of x minus 1. Don't believe me? Go ahead and factor it out, and you will really realize that it does equal 2 sine squared minus sine minus 1. All right, now I'm going to use that zero product property. 2 sine of x plus 1 could be 0, or sine of x minus 1 could be 0. All right, this first one I'm going to subtract 1 and divide by 2, so I get sine of x equals -1/2. So I'm going to go to my unit circle. Where do I see sine, or the y value, as -1/2? Well, let's see. It happens that here at 210 degrees, and also happens at 330 degrees. So 210 degrees and 330 degrees are the two locations on the unit circle where sine is -1/2. All right, let's continue on here. This is the left side. The right-hand side, sine of x equals 1. That was easy. All I had to do is add 1. This is pretty simple. Where is sine 1? It actually only happens at one place on the unit circle at 90 degrees. At the very, very top, 90 degrees, sine is 1. So there's my two answers to that problem. All right, the last problem is going to be a little bit more advanced. The last problem involves me having to use my identities. Because the good thing is I want to factor this. I see a 0 here. I definitely want to factor. But the problem is I can't factor it because I got a sine squared and a cosine. Two different trig functions. Well, here's the trick. I'm going to replace sine squared with something that involves a cosine. And watch what I'm going to replace it with. I'm going to replace it with 1 minus cosine squared of x. So hopefully you've been paying attention to my other videos on using the identities, because I know that cosine squared of x plus sine squared of x equals 1. Therefore, I could replace sine squared with 1 minus cosine squared. Do a little bit of distribution. 2 minus 2 cosine squared of x plus 3 cosine of x minus 3 equals 0. Let me combine some like terms here. So I have -2 cosine squared of x plus 3 cosine of x minus 1. The 2 and the -3 do make a -1. Now I just got to figure out how to factor this. And this might take a little bit of work, but I bet we'll figure it out sooner or later. Let's see here. -2 cosine of x times a positive cosine of x. That will generate -2 cosine squared. Then I need a 1 and a 1, because the only way to get that 1 in the back is 1 times 1. But let's see here. I believe I need this guy to be negative. That way when I multiply the outsides together, I get a positive 2 cosine x. I want this guy to be positive, so I get a positive 1 cosine of x in the middle, and together the positive 2 cosine and the positive 1 cosine makes the positive 3 cosine. Now I just got to solve each one of these. This guy needs to subtract 1 and divide by -2. So I get cosine of x equals -1 over -2, which is 1/2. Again, subtract the 1, divide by -2. This guy is going to be cosine of x equals 1. All I got to do is add 1 to the other side. So I got to look on my unit circle. Where do I see cosine is 1/2, or where do I see cosine is 1? Okay, I see cosine. The x value at 1/2 is at 60 and 300. So let's see, I'm going to write those down. 60 degrees and 300 degrees is where cosine is 1/2. And cosine is 1 at 0 degrees. So cosine is 1 at 0 degrees. Now once again, I could say 360 degrees, but remember there's actually infinite solutions if I think about adding or subtracting 360 degrees times n. But if I'm only focusing on answers on the unit circle, then 0 would be the answer I want. Alright, hopefully that was a not too bad of a video over solving trig equations. There's actually going to be some more videos in the future over solving trig equations because we'll get into some a little bit more complicated ones. But that's a pretty basic video that covers a lot of the best examples that you're going to see.